Hi, I'm Andy Colson. I'm also known as Austin Light Guy. This name derives from, I guess you could call it a hobby of automating my home Christmas lights. I've also been known, along with my buddy Richard, to be seen around town in wearable Christmas lights. Now, I've been playing around with Arduino a little bit, so with the release of the LabVIEW toolkit for Arduino, I thought it'd be a good opportunity to kick the light suit up a notch. In the past, my light sequences haven't been that sophisticated. I basically use the controller that I cut off of a commercial string of lights that has a few basic built-in light sequences. The power for the light suit comes from these packs of rechargeable AA batteries. They feed into an inverter that basically runs through the sequencer and powers the lights. So I've got my light suit with some static predefined light sequences. My friend Richard has a similar suit with predefined light sequences. And I've got the red autonomous cape, which has no light sequences. I've also got a couple of light stabs. Now my plan is to have a backpack. And the backpack would contain probably a laptop running the software and attach the hardware necessary to play some music and to wirelessly synchronize all these devices with the music that's playing. So how am I going to pull this off? Well, as I mentioned, I'll have LabVIEW running on a laptop. I'll use the Arduino toolkit for LabVIEW and some sound and vibration measurement components to convert power levels of certain frequency ranges into signals on the digital out pins on the Arduino. Some of those pins I'll connect to a triac board locally to power 4 channels of lights on my suit. The rest of the pins I'll connect to some XBee modules. These XBee modules make the wireless portion of my project really easy. They're basically these inexpensive transmitter receiver modules. They can be configured via simple AT commands to automatically convey the signal at the input pin on a transmitter to the corresponding pin on each of the receivers. So I'll configure one of my XBees as my transmitter and several others as receivers. One will be in Richard's suit and drive 4 channels of triacs on his suit. One will be in the red autonomous cape, and I'll have one in each of the stabs. Taking a very short look at the VI, I basically have a GUI with some output indicators, a waveform graph, and an octave graph, just for convenience, and a prompt for my sound wave file. I basically initialize my Arduino, read sample data from the song file, convert that into a waveform. I use some components from the sound and vibration analysis measurement suite to display the octave graph of that, and also to do some spectrum analysis on the waveform and convert the spectrum into power levels of certain ranges of spectrum, which in turn drive the LEDs. So the result, if we select a sound file and start our VI, is a pretty good synchronization of our digital out pins to the incoming sound. So looking at the build out, I've basically got my Arduino here connected to the laptop via the USB cable. I've got a breakout board that I bought on sparkfun.com that basically gives me a convenient way to connect my XBee to the digital out pins on the Arduino. I've also got 4 of those pins connecting the triac board that drives the light suit strings on my local light suit. I've got a similar setup for Richard's light suit. Here I've used a lily pad breakout box with a XBee on the other side of it, also attached to a similar triac board. We're seeing the back of it here. And then I've got a 2-channel version for the light suit. I actually cut a chunk out of one of these triac boards. It was an easy way to save time, gives me the same triac kind of circuitry, but it's basically the same setup. An XBee, 2 channels driving 2 triacs. For the stabs, I have a really simple breakout board on which I've mounted the XBs, and I just take two channels and use those to drive transistors, then in turn drive strings of LEDs off of a 12-volt power supply.
Looks like it's working as expected.